Good morning, everybody, to this Wednesday. I have to remind myself what day it is, where we are continuing getting some properties ready to find derivatives of more and more complicated functions. As always, just so I know I'm not just talking to myself, can someone just confirm that they can both see and hear me, and we will get going. All right. Now, it is worth reviewing yet again the properties that we have so far. If this is annoying you, good. That's exactly my goal. It should be repeated so much that it is annoyingly obvious and you know it so well. So, we have the power rule that says that if I want to find the derivative of x to the power of something, then I can put that exponent in front and the new power of x is 1 less. All right. But in order to get to the power rule, I need to have some other properties to actually get me to that isolation of x to the power of something. For that, I have, in no particular order, constant times a function. So by the end, I would have written these down many, many times. So I guess they're important. Maybe I'm just trying to keep myself busy. Everything I'm saying is important, and you should be able to make this list as well. If I have a number times the essence of the function, whatever that might be, something that involves the x's, that a cannot be an x, right? Then I can do exactly what I want to do, and that is leave the number out in front, focus on the derivative of the essence of the function, and move on with your life. So these properties are ones that I take for granted very easily because they say things the way I want them to be. And I almost don't even think that this should be verified by way of the limit definition. We can't just make it up because we want it to be like this. Next, we have the sum or difference property. Don't know why the power rule is called a rule, but the others are called properties. Whew, that was ugly writing. I can do better, I apologize. Okay, well, I can't do better, but I'm going to try. And the more I try, the more weird it looks. That says that if I have to find the derivative of, a function, but it's made up of multiple terms, maybe an f and a g. I can look at the derivative of each one separately and put them together in the way the terms were put together originally. It's pretty much exactly, best case scenario, this is exactly what I would want. To the point where it feels almost made up, like how can things be so perfect? Lastly, I have what I'll call the constant property. These guys don't really have names. I'm sorry. Why don't you have a name? Why can't I write better? Wow. There's no answer to any of that. I don't know why they don't have names, and I don't know why I can't write better. If I have a constant function, I know that's horizontal. Slope of horizontal line, 0. Okay. So all these are the ones we have so far. And we've practiced and practiced a good number. And if you need more practice, I assume that you do that. And if you need to go back and review, there's a prerequisite little gap in your knowledge. You need to go and fill those gaps. They're not going to fill themselves. But I'm happy to discuss that with you if you're not sure. Something feels off and you don't know what. we can figure it out. But this derivative concept, an idea, and the big picture of what we're doing needs to be very, very solid if you want a smooth ride for the rest of the course, really. Calculus is all about this derivative. In different forms, but it doesn't really change. We'll see. Okay, so I want to make more complicated functions. Now, I am limited to the essential fundamental type of function. I'm sort of stuck with powers of x for now, and that's okay. That's okay. But within that, I at least want to handle anything that's possible. Now, I have some basics like a number in front, a constant function, and I can add and subtract functions and still find the derivative. Then the next one would make sense to ask, well, what if I have, I'm going to leave a space here, what if I have to find the derivative of a function that has pieces multiplied together? Certainly that is going to come up a whole bunch. So we want to know, how do I handle a product? Now, for some reason, this is called the rule again. I don't know why. It's still a property. The question is, what do I do with that? For example, now there are problems, but I'm just going to make a random example. If I have y equals, what should we say? Let's say x apparently. X squared plus 1 times 3x minus 7. That's a function. That could come up. And I see I have these brackets multiplied together. Now I certainly have the option. Let's call it option 1. Quite often, to first simplify and multiply these things out to see what I have. First one's 3x cubed. Maybe then you FOIL according to FOIL. Outside ones, negative 7x squared. Inside ones, 3x. Last ones, minus 7. Totally good option because foiling is so easy, right? You've done so much of it. It can't go wrong. So it's reliable. And then I can go and say, ooh, let's mix it up. Let's go little d notation. Yeah. We don't see this guy enough. It'll come later. But this is just another name for the derivative, right? And I can quickly do my properties that I have so far. Some difference property is going to happen first. Then that's going to allow me to isolate each term. Within that term, I know that the constant times a function keeps the 3 in front. Then eventually I'll be able to use the power rule. That exponent's going to come in front as well and multiply with the 3 to give me a 9. The new power of x is going to be 1 less. And as I slowly do the detail and get used to it, I'll be able to very quickly find the derivative. But let that happen naturally by doing the detailed versions enough times for you. I've seen people, they go to quickly get the answer. They skip all the detail, right? Just find the derivative. When they're not really ready for it. I can't say when you're ready. You'll know when you're ready. And that is when writing out those detailed steps and explaining the property you're using on every line, when that gets so annoying and so obvious, then maybe you're ready. And if the question doesn't specify, it just says find the derivative, you can do it in one line if you're ready. Okay. So that certainly is option 1, sure. But it's not going to take much for me to imagine that if I have more terms in the bracket, or those terms inside each bracket is messy and difficult, or I have multiple brackets, then multiplying these out could actually be quite time consuming. And I could actually make a mistake on the way. This one was fairly easy. 2 terms each. Each part isn't complicated. It was manageable. But if this gets worse in terms of what the brackets look like and how many there are, yes, this option might take me a while. It might not be the most efficient. Is there another option? Now let me make it clear. Yes, there is. I would have to be sure where this comes from, I would have to go. Now, I'm not going to do the whole thing because we don't need to. It's a little of it sidetracks us a little bit. I'd have to go and say, set up the limit definition on this function. So it'll be the function at x plus h, which will be x plus h g of x plus h, minus that whole function at x, and figure out what that is. There's some trickery involved that can help me figure that out in general, but that is what has to be done to establish a new property. There is no way around it. And I might want this property to be similar to the sum difference property. Saying, well, if I look at the sum difference property, well, I had 2 pieces added and subtracted. I just separate them and then put them together in the same way. So why wouldn't I be able to do the same thing here? Of course, I would want it to work like this, but I have a question mark still. I'm not sure. Let's have a look at this example and see. I know what the answer is. This answer is correct. This answer is correct. Actually, I forgot to do something. Oh, no, never mind. Never mind. This answer is correct. Let's see what I get if we try and find the derivative by looking at the derivative of the first bracket times the derivative of the second bracket, right? Certainly, if I look at the sum difference property, it's as easy and straightforward as I could have hoped. It would be super nice if this product rule is also as straightforward and simple as I would hope it to be. Looking at each of the factors and their derivatives and then put it together in the same way. So that would require this line, okay? Again, I'm just trying it. So the first derivative is 2x, of course. The next derivative is 3, and that would give me an answer of 6x. And you see, I'm not even close. This isn't even close to the same. It was the same original function. Answers? Nah, not correct. Unfortunately, whether I see the proof and understand the proof or not, this is unfortunately not how I handle the product of 2 functions. This is not complete garbage, but doesn't work like this, unfortunately. It's a little more complicated. Only a little, not a lot. So what is it? I'm going to write it in a version that you might see in the book. It's a little nicer to look at it this way, I think, with prime notation. It is the derivative of the first times the second plus the first times the derivative of the second. Not because I want it to be, I don't want it to be, but because it is. When you go through the mess of this general limit definition on this kind of function, and I'm happy to show it to you, it's just sidetracking us. It's not the focus of what we want to do right now. It's a little more difficult for sure. If you go through the motions, what comes out of that is what it is. And this is what it is. Now, there's some symmetry and nice aspects to this, making it a little bit easier to remember. It's not that bad, but it certainly isn't ideal. But it is what it is. What I feel is irrelevant. I want it to be simpler. Well, it's not. Suck it up. It's also not that bad. Just say it over and over to yourself, and it gets easier. Now think of it as I have a first factor and I have a second factor. First multiplied by second. The derivative of that is the derivative of the first times the second, then flipped around, plus the first times the derivative of the second. So it's not that bad. It's not that bad to memorize. But even if I see the proof, it's not going to help me memorize it. I just have to remember. Say it over and over. Derivative of the first times the second, plus the first times derivative of the second. Okay. How do we feel about that? Recognizing that how we feel is completely irrelevant because the proof is what it is. Sorry, I tried to unmute you, but you still have background noise. How I feel about it is irrelevant. It is what it is. Okay. Now the question is only, let's practice and use it. Using it is important. So now, this was all bad news. Bad. What is the correct version of option 2, the product rule? So let me rewrite this. I don't remember what I wrote. X squared plus 1, right? Yeah. X squared plus 1. No. What am I doing? Back it up. I'm just trying to rewrite the function here. Whoa, random line. 3x minus 7. Okay, that's not the same function. Why am I paranoid now? My skills of copying stuff down are lacking, to say the least. Okay, so now I see. Okay, it's the product of two things. That is how my original function is made. I can break it up into pieces, but those pieces are multiplied together. That means product rule. So I have, following the product rule, the derivative of the first times the second plus the first times the derivative of the second. Now see here how quickly we are leveling up and how quickly we are leaving the limit definition behind. Those are things you have to do. You have to understand ultimately what we are doing when we talk about the derivative. What are we talking about? What is the limit definition? Where does it come from? What is happening at that bottom level of detail and messiness? But for now, we are trying to establish all the things that we need to get out of that bottom level. Still finding the derivative, but in a more clean, efficient way. That means I need to look at different ways that the function could be made of smaller pieces. Added together, subtracted, constant piece, number times a piece, or pieces multiplied together. Those all need to be established if I want to step away with confidence away from the limit definition. So this is now practicing how to handle a function that is the product of two smaller, simpler pieces. Now I've now taken the original derivative and rewrote it to a longer thing, but the derivatives that I now have to find, these two, are much easier. And now I'm back to my basic properties, because the first derivative here requires a sum property. And then I have a power rule. And then I have a constant property. So it's 2x. The 3x minus 7 comes down, waiting for me to resolve the derivatives that I still have. The x squared plus 1 waits for me to do what I need to do, which is find the derivative of 3x minus 7. In finding the derivative of 3x minus 7, so that's this one here, and that's this one there, that's next. Can we list collectively? There are 7 of us, excluding me. In finding that derivative of 3x minus 7, can we list all the properties that goes into finding that derivative? You don't have to list all of them. Just start saying properties that go into finding this derivative of 3x minus 7. Can you see the properties that are being used? Just list them. It doesn't even matter which order. For now, I just want to see. Can we see all the properties? Definitely constant times a function. Constant times a function. Definitely power rule, because there's an x to the power of 1, right? Okay. Any other properties that go into this? Actually, a lot more than you might think. Constant property, because the 7. Absolutely. Constant property. We've missed the first one that gets us to any of these. We overlook them. And my theory is that by overlooking them, we run into silly mistakes later when things get complicated. And we're heading towards that. There's one more property, arguably the most important one, because it comes first. I can't look at 3x. It's not isolated yet. I can't look at 7. I need, well, technically the difference property, but if you say some difference, totally fine. Because it's a minus in this case, difference property. Or you can always say some difference, that's also fine. All of them in combination allows me to say 3. But of course, I've done a ton of these. It's super easy for me. I need to make sure, and you need to make sure for yourself, that it's super obvious why it's 3 and nothing else. And if it's not, go back, rewatch videos, practice more, do whatever needs to be done. But my best advice, as annoying as I sound, saying the same things over and over and over, in the off chance that someone is hearing this for the first time, you have to build on a solid foundation. Or in a month from now, it's all going to fall apart. And it's going to be so hard to build up again. Build it as it comes up, layer by layer, and make sure it's solid. You decide for yourself whether this 3 is super obvious, because it needs to be. We're now heading into more complicated properties that help us rewrite to simpler derivatives that use my original 4 basic properties. So now it's just a matter of, I can totally leave it like this, but I want to simplify because I want to match it with my answer up here to see if they're actually the same. So I have an extra objective, and to see if I get the 9x squared minus 14x plus 3, which I hope I get. So let's see here. I have a 6x squared, multiplying the 2x in, then a minus 14x. Multiplying the 3 in, I get a 3x squared and a 3. I'm going to zoom out because I don't like scrolling up and down so much. And hopefully everyone's convinced that we get the same answer. So as not obvious as it may be, why the product rule splits these pieces into multiple terms, it's necessary to get the answer that I need to get. There's only one right answer here. The derivative of a function is a specific other function. Regardless of which route I take, it needs to get me to the same answer. Okay. So we have the product rule. Now, because I know some people are, it takes a while. They're a little shaky. It takes a while to get on top of all this, to understand the big picture, to understand the different properties, what we're trying to do, what we're saying, when we're saying it and not saying it, and all kinds of things. And we have more than 7 people in this class. Not all of them are watching this video. Actually, some are watching on YouTube, fair enough. It takes time. So I want to give you time. All I want to do is the product rule, because there's enough to do already just in that. And there's time to let me know if you have a question. It's a discussion. Yes, technically I guess it's called a lecture, but it's more of a discussion at this stage. As I do things, if you're not liking it, I can't guess. You have to say. So we have a bunch of product rule questions. Oh, that's nice. I like it. I like it. Now, I want to build up to it, but it does say state each property. So I'd rather do fewer, at least one of them, but do it in excruciating detail at the risk of annoying you completely. What shall we do? I want to use the product rule specifically. So let's try number 4 because it's not too overwhelming. Problem 5.3, number 4. Because, and the test question may do this, because it says use the product rule, I have to use the product rule. And not multiply it in, simplify it first, and then go to the derivative. It says use the product rule first, which means I have to. So 2x, x squared plus 1. It doesn't have to be complicated to practice. The principles are the same. So now I need to see multiplication with 2 things so that I can use the product rule. I have my first and my second. Product rule says, get rid of this line here. Product rule says, I'm going to do it over here so I have enough space. Derivative of the first. Now remember, maybe you didn't see the question here. It says state each property. I'm going to do this one in a lot of detail, just to be sure. If you are super comfortable already, I apologize. Grab a pillow, have a nap. I'll wake you up in a second. But not everyone is at that stage. Derivative of the first times the second plus the first times the derivative of the second. That is what it says. It doesn't say anything else. That is what it says. Oh, so I have to say here, product rule. This is now a detailed one we're doing. So like I said yesterday, there are different versions of the question. One question is use the limit definition to find the derivative. Okay. Other question is find the derivative, but say what property you're using every step of the way. That's what we're doing now. And the last question is just find the derivative. I don't care how, I don't care what you show, just find it. Of course, that's the last one you should be doing when you're ready for it. And we'll do that for the next ones. Now, let's address this. Which one? Now let's address the first one. Actually, yes, let's do it. I can say it's 2 times the derivative of x for this one step at a time. And for the other derivative I have to do, I can say it is the derivative of x squared plus the derivative of 1, of course, brackets. Which properties have I used in that line? This is where you say stuff. And feel free, if you're watching on YouTube, you can still say stuff. There are 10 people. You don't have to be quiet. I'm looking at the YouTube chat. No one is saying a thing. You are not exempt from chatting. Constant times a function for the first one. Constant times a function. And I've used the sum property. Squeeze them in. Okay. Then I am going to, I'll just do it all. I'll just write it down and you think about what I've done. Not doing too much, but I am doing maybe a couple of steps like that. So I have done something for each of the derivatives that were there. I've done something. I've used properties. Which properties have I used? One? More than one? Which ones? Only by trying do you know where you're at. And if it's super easy for you, great. But if it's not, now's the time. Power rule for sure. Because I had powers of x, right? There was more. There was a constant property as well. I want to give these guys attention because without them, honestly, without them, I would not be able to do anything. If people don't realize their importance, well, I'm trying my best to emphasize it. They might just seem negligible because they're so straightforward, but they are crucial to all of this. And now it's a matter of simplification, which isn't too bad. I could totally do that if I wanted to. I will emphasize simplification is optional. Stop right there if you want. It is the answer. But if you feel like you want to simplify, go right ahead. But then make very sure that your simplification is correct, or just stop right there. Later on, here's my view on simplification. You've done so much of it in high school, in your prerequisite courses. I don't feel it's appropriate for me to beat it to death further. It's pretty much already dead. You've done so much. You're probably sick of it. I trust that you can simplify algebraic expressions when you need to. We don't need to do it every time. When we have a need for it, like the question says something, or I have an answer I need to use further and I want to simplify it as much as possible, when I have a need, then I will simplify. I'm not going to simplify just for the sake of simplification. Okay? So you are more than welcome to stop right there with the box. But you are welcome to finish the simplification if you feel the need for it. I don't. This is just find the derivative. Whatever form, all of these are the derivative. Doesn't matter if it's as simple looking as possible. I don't care. All right. New. Okay. So let's see where we're at. Okay, so we have done the product rule. We've talked about the product rule. It says what it says, no more, no less. Okay. In some books, you might see these guys swapped around. I don't like that. I'd like it this way, for reasons we'll see tomorrow. And if you do other other math topics, vector algebra and things like that, then the order of these things are actually important. So I've memorized it like this. Whichever way you memorize it, because it's a plus, you can technically swap the terms around, whatever. Okay, so if we look at the problems, we'll see here, what if we have, I like number 7. Number 7 looks nice. I like it. And I hope that you feel like I do, that if I look at the function in 7, I don't want to multiply those out. I don't want to simplify that first. That seems like a lot of effort. I'm pretty lazy. I want to find the derivative. And I have a property that handles multiplication. So why not just do that? But I also now see that I have 3 of them together. What do? I have 3 brackets that should be multiplied. Well, let me just set it up one step at a time. I have an x cubed minus 1. Individually, these brackets are not complicated. I have a 1 minus root x. When the time comes, I'm confident I can handle it. I have an x cubed minus x plus 1. X cubed minus x plus 1. All right. Now, again, the power rule, not the power rule. Well, yes, the power rule too. But the new one, the product rule, says what it says, no more, no less. And this is the only one I'm going to bother memorizing because it's the only one I will need. It says what to do when I have 2 things multiplied together. 2, not 3. 2. And yet my question, I have 3. What do? All I need to do is group 2 of them together. Come on. It doesn't really matter which 2. Let's maybe take these 2. That'll be my first function. And that'll be my second function. The product rule only works for 2. Now, my goal now is to not simplify them first, right? I know they're not big, and you definitely have a desire to FOIL it out, but sometimes I'm not going to be able to do that. Right now, we don't have a lot of variety in our functions to see why that would ever come up. I am resisting the urge to FOIL anything out. What do? Okay, because I don't want to rely on that. Sometimes it's not going to be possible. And I still need an option. The product rule still works as long as I see 2 things at a time. Okay. Now, I'm going to do this a little faster. I'm not going to write the properties. I know the question wants me to, but I need to stay awake. And maybe you don't have a pillow. You could hurt your head. I know what to do with the product rule when I'm looking at 2 things. Pink is my first, blue is my second. It's the derivative of the first that I'm not doing right now. I will think about it later. I'm setting up the product rule times the second plus the first, whatever is pink, times the derivative of the blue second one. People tend to skip this line. So many people. And instead of seeing the derivative and preparing for what's next, they want to do this bit, for example, in one go, immediately. And they want to do, when this other derivative comes up, they want to just do it. It's a risky game. I'm not saying you can't, but know your limits. Know your limits. Get it? Limit. No? Okay. Know what you're able to do. The less you write down, the more you have to keep track in your head. And that's where things get shaky for me. But I know if I've written it out like a plan, the product rule is what I've applied. Now I'll look. What still needs to be done? Oh, this derivative? Okay. And this derivative? Okay. But having something on the paper, on the page, I can see and keep track of what needs to be done and focus on that only and not remember all the other stuff. Exactly. Know your limits and play within them. Yeah, exactly. So if you write down less, totally fine. But that requires a lot of keeping track of everything. And that's where I make mistakes. And I don't want to make a mistake. So I'm writing down this line, which really didn't take that long. Minus all the rambling, it was quite actually fast. Now I see, oh, this derivative, I'm going to make it green. It's not the best green, but I'm going to go with it. This derivative needs to be resolved. And when I look at what is inside the square brackets, it's another product, which requires the product rule, which I will now do. The derivative of the first, and again, I'm not doing it right now. I'm writing down what the product rule says, and then I'll see what's left to do. Derivative of the first times the second, plus the first times the derivative of the second. All of the green, that is green, all of that is multiple terms. It needs to be multiplied by x cubed minus x plus 1. Now I know this looks pretty bad. And you might be thinking, why didn't you just FOIL it out from the beginning? Why make it so bad? Because like I said, our functions are quite simple right now. So we have the option of FOILing it out. There are other functions we will learn, and then I don't have the option. Yet I still need to find the derivative. So I can practice that now. And of course, then I have this extra term here, right? So I'll just write it over here because I'm running out of space. Again, I'm not wasting your time with things you're never going to see. Actually, this guy didn't require much, but let's just leave it. He was already ready to go, but we needed to figure out the green one first, maybe. So now I'm over here. Now all of the derivatives are straightforward, original basic properties level. Let's see if we can do it. Stop me if you're not happy. This first derivative over here, 3x squared. And then, of course, the bracket 1 minus root x is still there, plus. The x cubed minus 1 is still there. Derivative of 1 minus root x. Now, this is where you decide, what do I need to do to handle this square root? Maybe I need to see it as x to the 1/2. I get people that just memorize the derivative of root x is 1 over 2 root x. And they are happy with that. Great. That might be you. That might not be you. Know your limits. Know how you want to do it. So regardless of which one you're at, maybe you want to write here negative 1/2 x to the negative 1/2. Maybe you want the root version. It's up to you. They are equivalent. Remember your brackets, right? Then I have a lot of stuff that just needs copying down. Same as this guy. This guy needs copying. This guy needs copying. Everyone needs copying. Well, not everyone. This last one, right? There's still a derivative here to figure out. Not hard. Basic properties. But a lot of things happened. And suddenly when you look back, whoa, look at everything I wrote down. I'm kind of impressed. Sure, you could look at your options, and if there's an option to FOIL it out, that is an avenue you might want to go down. Not always going to be possible. Whether you believe me or not, the product rule can handle more than two things being multiplied together. It's going to get messy, yes. But if I write down enough for myself to keep track of everything, who cares how messy that answer looks? I will not be simplifying that guy, but I also don't need to. I found the derivative. It's right there. It's right there. Look at it. I'll put a box around it for you. It's there. If you want to simplify it, do it yourself. I'm not doing it. I also don't need to. Finding the derivative and simplifying algebraic expressions, those are two separate questions, in my opinion. Right now, we are practicing how to apply the derivative properties. To find derivatives of functions, I wouldn't even dream of using the limit definition for. And I can look at a function being made up out of pieces that are added, subtracted, multiplied. I need properties for all of them. And then, of course, you could say, oh, well, what about divide? Yes, of course I need one. That is for tomorrow. What is happening tomorrow? Tomorrow you are watching a video, pausing it, rewinding it, slowing it down, speeding it up, doing whatever you want to do. But it's sometimes nice to just watch it at your own pace, work through something at your own pace. In that video, the product rule might be repeated, so feel free to watch it again or skip it or do whatever. But I do have the issue that we have added pieces to make a function. We have multiplied pieces to make a function. Surely we can divide pieces. Think of rational functions. That's division. How do we handle the derivative of that? So I need another one for a quotient. That is your task tomorrow. And then we are nearing the end of this list. That's not the end, but we're nearing the end. With each one we add, it gets more and more complicated. Build your foundation. If you're not ready, don't go ahead if your foundation isn't solid. You're building on it. If it's shaky, it's going to fall apart. It happens every single semester I see it. Regardless of my best advice, there's always someone that ignores it, and I don't want that to be you. I don't want that to be you. Build on a solid foundation, and you're giving yourself the best chance for success. And I guarantee you, if all the effort you put in now, the last month, November, is going to be smooth sailing. If you've put in the effort now, or it'll be a disaster if you didn't. That's up to you which way you want to go. Up to you. I can only give you advice. Any general questions up to this point?
Please remember to click the like button if you enjoyed the video, and to subscribe if you want to be notified of more videos. Thank you.